Immediately invoked function expressions, or IIFEs, are basically JavaScript functions that run as soon as they're defined. You will also hear them being referred to as self-executing anonymous functions. IIFEs contain two parts. The first part is the grouping operator, which contains the anonymous function. And the second part is the immediately invoked function expression. I know this is too complex, so let us take time to break this down using a normal function. One of the features of JavaScript function is functions in JavaScript are first-class function. And one of the properties of first-class function is a function can return another function. So let us define a function called greet, which returns an anonymous function. The anonymous function has a parameter of name, and we can console the result. Let us invoke the greet method. And we can see that it basically returns another function. To prove this, let me console log that. And we can see that it is basically returning another function. So in order for us to access the anonymous function returned from the greet function, we can just use the pair of brackets. And we can see it is currently console logging undefined. But if we pass in an argument, we can see that it changes to Kelvin. That is the same way that IIFEs work. So you can think of the grouping operator as a return statement. Then the second part is basically what executes the function. So in order for us to work with IIFEs, we can try console logging a result. So let us just console log here in the IIFE. And we can see that it is immediately executed. We are also able to pass in arguments using the second part, which is the one that is executing the anonymous function. In this case, Kelvin. And we can be able to access that parameter. So here, Kelvin. So what are some of the use cases of IIFEs? The first one is to prevent pollution of the global namespace. And a good idea for this is think about libraries, for instance, created by many people who probably don't know each other, and they probably might be using the same names. So if everything was written in a flat format, you might end up overriding functionality from a different libraries, which will be chaotic. So the idea is to prevent pollution of the global namespace by limiting the number of variables and functions attached to the global object. Let us have an example. So let's say I have a function called name. And basically it console logs name1. And this is my library. Then we have another person who has written a totally different library that also has the same function name. But this one console logs name2. So when we run the function, let's say we call name, we can see that the function with name2 overrides the function with name1. That is not desirable. So to cure this, we wrap our functionality in IIFEs. So in this case, I will take my function, name1, and have it executed or contained in an IIFE. even if I have name2 before the IIFE, you will see that name1 is not overriding name2. And we are executing name2. The second use case for IIFEs is basically it is used for the modular pattern. What is that? We are able to create private and public variable methods. And this is just an example that we are also looking at. By wrapping functions in an IIFE, for instance, in this case, name1, it is not accessible outside the IIFE. But we can be able to pass it outside by using a return statement. So let's say we have a return statement and we are able to define a function on the returned object. So let's say maybe get name, for instance, which will be an anonymous function. And the anonymous function will execute the name function. And the name function, we can be able to pass in the a parameter, but in this case, let us just use x for lack of a better name. So in order for us to access get name, that will be very simple. Let us get rid of the first one. So think about it. We can be able to assign the entire IIFE to a variable, which also boils down to the idea that functions in JavaScript are first-class functions. So we are able to assign functions to variables. And in this, let us just use a constant in this case. So const library. And by using the library, we are able to access the public method, in this case, the getName. So getName, library, dot getName. And we can immediately see that it executes the name function, which is private. We are not able to access this outside the IIFE. So it is a private method. Then we have a getName, which is a public method. The final use case for IIFEs is it is used in for loops. So for instance, before year 6, in case you wanted to execute, let's say, callback functions within a for loop, you would face a very interesting problem. In this case, we'll have, let us just write a for loop, var I equal to 0, then I is less than 10. Then we can increment I. And we can console the results of I. And you can see we get 0 to 9. So that is correct, working fine. But what if we were to console log the results in a callback function? And in this case, we can just use the set timeout to demonstrate this example. So set timeout, which has a callback function. And we can see that it just returns 10. What is happening here? It is because of the overriding. It's because var is globally scoped in this case, and it is being overridden in the global scope. So it returns the last value, which is 10. Notice it is 10 and not 9. So basically, every time it is being incremented, the last value, which is 10, is what is being console logged. So in order for us to fix these issues, we used to use IIFEs. And how does that work? So let's say we have an IIFE, and we shall use a different parameter name just to show difference, and have the set timeout function inside the IIFE, then immediately execute it and pass I to it, then we can access the I through the Y. And we can already see that we are getting the correct results. So in this case, 0 to 9. So this is what we used to do before year 6. But at this point, we don't have to worry about this. We can simply replace var with let, and that will fix the issue. No need for IIFEs any longer. In this case, it is Y, I. And that fixes the issues. And why this works is because let is block scoped, while var is function scoped. So we have a block of code, and every time the loop runs, it is creating the let keyword is being scoped differently every time the loop runs. So we get the correct results. If you have enjoyed this tutorial, don't forget to hit the subscribe button, hit the like button, also leave a comment of what you would want to see next in these tutorials. Thank you and see you in the next one.